Hello friends, welcome back my YouTube channel MS Maths. In this video, I will start real analysis basic course, which will helpful for IIT JAM, CSIR, and GATE. So basically, in this particular video, I will cover basics, and it is the part 1. So in the basic part, I will discuss the basics of set, bounded set, unbounded set, Supremum and Infimum of set. So I will discuss these topics in this video, and further next topics will be in the next part. You can find it on my YouTube channel MS Maths in the playlist of real analysis. So I'll start with the topic and with the standard notation that is used for n. N is used for this kind of n. This will be written like this. This kind of n will be used for set of natural number. Okay. So there are basic notations are here. I will discuss them. So these are like this is the set of natural number which is started from 1 to up like going to infinity. Similarly, z is the set of integer, okay, in which like there are negative and positive and 0 is there. Q is rational number whenever we will have this kind of p by q, and this will be, of course, p and q will be the integer other than 0. Q should not equals to 0. This will be the rational number. Okay, and after that basically union of all these like integer and rational and irrational, it will be a set of real number, not natural real number. It will be a set of real number, and after that C will be a set of complex number. Then C is nothing but a plus minus iota b, where a and b belonging from the set of real number. Okay, basically for like irrational number, there are no standard notations. Like people are also using QC, people are also using that R minus Q. It means number which is not rational is called irrational, or rather than we can use R by Q also for this. Okay, so now what is the set? We all know set is a well-defined collection of distinct object of like distinct or object is called set. So it means that in the set there is no repetition of element will be there. For example, if it is like this 1 2 3, or if it will be again 3 will be there, then it will not be a set. So distinct elements would be there, so this will be a set. Okay, now next. So empty set, what is the empty set here? Or for example, the example of set is nothing but natural number. If my a is n, then it will be a set of natural number. Okay, so now here it is nothing but okay, so it is basically the set, and this is called the set of natural number, in which no like each and every number will be like presented only once. No number will be in the repeated form. Okay, next we have an empty set. What is the empty set? Empty set is nothing but in which a set with no element in is called empty set. Basically, there is no element in that set, and we are denoting with phi. So whenever we have phi, the cardinality of this phi is going to be 0. It means this kind of set is called empty set. No, it is not meaning that you have set and there is the element 0. 0 is considered as an element. It means if it is a set, then the cardinality of a will be 1, because there are one element present. Okay, and another thing is that if it is written like this in the curly braces, this is also not an empty set. The cardinality for this is also going to be 1. Okay, this is not an empty set. So next we have an interval. So what is an interval? Okay, then what is the example of empty set? We can consider an example. For example, I have a set basically in which I'm considering x belongs to real number for which x square will be 0. There does not exist any kind of real number whose square will be less than 0. It means whose square will be like negative. It means the cardinality of a will be 0 and my a will be an empty set here. Okay, this is the meaning of the empty set. Next, interval. What is the interval? A set basically in this kind of this thing, if I is a subset of R, is said to be an interval if a and b belonging from that interval, or a and b are belonging in that I, where x is in I. For every x, this x will be in this particular case. It means it is a range kind of thing. Basically, it is the thing that in which we have, you know, the thing 0 and 1. This is called the interval. It means it is called an interval, and it means if I will take any kind of number from like this, if it will be 1, then it will be in the 0 and 1, or it will be like 0.5 will be in 0 and 1. This is called an interval. Like each and every real number should be in that in that particular thing. Okay, in that particular number a and b, that is lower bound and upper bound. We'll discuss. Next one is open interval. What is the open interval? Open interval is something that if you are representing it by open, this is the notation for this, in which the boundary points are not including in that interval. It means a and b are not containing in that interval. Okay, yeah, a and b will be in the interval, but not from the like element of that interval will like not contain a and b in that particular interval. Okay, so it is that every x is greater than a and x is less than b, and you know, the thing is that the range using this x will be the interval, or called open interval. Semi interval is that in which we are including a right hand side. For example, we are including the left hand side a but not right hand side. It is nothing but an interval in which a will be in that particular interval but b does not belongs to that particular interval. Similarly, this is also the thing in which we are considering the right hand side is containing in by that interval. Closed interval is that where a and b, the definition is this: a less than equal x less than equal b. This is the definition of closed interval. After that, we have ray. Ray means like that it will start from a point and go up to infinity. Okay, either it may be positive infinity or like negative infinity. For example, it is like the thing, if I will start from here a, and it will go up to infinity. This is called this is called the right hand ray. Okay, similarly, if it will start from here minus of a, then this will go up to minus infinity. This will be like left hand side ray. Okay, these are the types of rays are given here. Okay, next one is that bounded above set. What is the meaning of a set which is bounded above? Means that the proper definition is given here that a set A, a subset of R, is said to be bounded above if there exists some real number, say k is a real number, such that every element of A will be less than or equal to that k. It means no element should be present in that particular set which is greater than of k. It is called upper bound, and the set is called upper bound, bounded above set. Okay, so for this we have some note points are here. I will write here. So whenever you will have any like number k dash, so this is the thing. For example, we'll take the example later. First we'll discuss the definition. So this is the thing: if you have any kind of number is there which is uppermost, or which is like there is no element present in that thing that belonging from the particular set which is greater than k. Okay, after that this will call be a upper bound or the bounded above set. Okay, any number, okay, any number, for example k dash, which is greater than of k, is also called upper bound of the set. Okay, upper bound of the set. It means there are two definitions. Okay, first one is bounded set, which is called in which there exist a k, not in which. K should not belong to the like particular like set. K can be any real number, but every element of that particular set should be less than or equals to that particular k. Okay, and if any k dash is greater than k, it means all the element will also be the less than or the strictly less than to that particular k dash. So it means it is also a upper bound of the set. Okay, and another, any bounded above set has infinite number of upper bound. This is a result. Because of that, if for a kind of set A, 5 is my upper bound. Let's say 5 is my upper bound. It means k is equals to 5. So 6 will also be the upper bound of this. 7 will also be the upper bound of this. It means there will be infinite number of upper bound of this particular set A. Of course, this is the result. This is the note point. Okay, next is going to be unbounded set, unbounded above set, which is not bounded above. It is called unbounded above. Now we'll take the examples. We'll start from the phi set. So first of all, whenever you will have this thing, so we'll find the is it a bounded above or like a bounded above or not. We'll just find and we'll see what is the upper bound of this. So first of all, this is what the empty set. So what is the is empty set like bounded above or not? So we'll just find yes, it is a bounded above set, and upper bound for this is R. So this is nothing but the upper bound. Okay, so every number from each and every number from real number will be the upper bound of this particular phi. Now this natural number, it will go up to infinite. It will go up to infinite. It means this can't be upper bound. No, it is not upper bound. Similarly, Z, of course, it will go up to infinite. This is also not upper like bounded above set. This is also not bounded above set. Irrational number is also not bounded above set. Real number is also not bounded above set. Will go up to infinite. Complex number will go up to infinite. So these are all not bounded above set. Similarly, we have some other examples like 0, 1. What is this 0, 1? 0, 1 is nothing but an interval, and it is open interval. What is the greatest value? Or if I will take 2. Okay, if I will take 2, for example, this k is equals to 2, then if I will take any kind of element from this particular open interval, that may be 1.5. Okay, it is belonging from this interval. Let's say this is my I. So 0.5 is less than of 2. Okay, any number, or we can find such kind of k free from real number, of course, then there exists at least one upper bound, or of course infinite number of upper bounds will be there. So we have at least one upper bound we can find. So it is what? It is that it is a upper bound. This is what? Bounded above. Yes, it is bounded above. And upper bound is what? Upper bound in this case is all element, like all positive real number. All positive real number will be the upper bound for this particular interval. Similarly, for this case, is it upper bound? Yes, of course, it is upper bound. Yes, also one is there. Okay, so in which all positive real number which is greater than 1. Okay, which is greater than 1, the same thing will be here. Or 1 can also be the upper bound for this, because 1 is not containing in this set. Similarly, 1 by n. What is 1 by n? If I will put natural number here, then it will be 1 upon n, 1 by 2, 1 by 3. Okay, and up to what? 1 by 1000, 1 by 1000, like 1 by 1 lakh. So it is going to 0. Okay, it is going to 0. So it is decreasing sequence. Okay, whatever the sequence, it is just decreasing. Just we should have an idea about that. What is decreasing? It is going to decrease. So what is the upper bound? Of course, there is a upper bound 1. If I will take any number greater than 1, this will be or any number greater than 1, that will be the upper bound of that this particular set. Of course, this is tending to 0. Then this is upper bound. Yes, it is a bounded above. So 1 will be the maximum value for this. Next one is 0. 0 is what? Yes, it is of course a bounded number. 0, 0, or if I will take 1, this will be the upper bound. 2, this will be the upper bound. 0.1 will be the upper bound for this also. Similarly, this one, this is what? It will be 1 upon 1 plus 1, 1 upon 1 plus 2, and it is also going to be decreased, or not going, yeah, going to be decreased, because this is 2 and this is what? 1.5 is going to decrease. So what is the upper bound? Upper bound is 2. So all the value greater than or 2 will be the upper bound, and yes, if it is a bounded above. So these are the example. You can understand the concept of bounded above and unbounded above. Next, what is the meaning of bounded below here? So the bounded below means that a set in which, okay, a set A subset of R is said to be bounded below, said to be bounded below if there exists some number k in which each number of that particular set will be greater than of k. That's just opposite of bounded above. Okay, the same thing is here. Note, I will write some note point. So first one is any number k dash is less than of k. If k is my bounded below, or like lower bound, then k dash is also be the, then k dash is also a lower bound. Okay, for the set. Similarly, there exists infinite number of lower bound of a bounded below set. Okay, there exists an infinite number of lower bounds. Okay, then next. One second. This will be here. Okay. Now we have what? Unbounded below set. Just opposite. There does not exist such kind of k for what k is less than or equals to each and every element of that particular set. Okay. Then after that, what is bounded set? This is the important definition. Okay, what is the bounded set? If a set A is bounded above, okay, and bounded below. So from the from the like this end, it should be bounded, and from this end, this should be bounded. Is called bounded set. A set subset of R is said to be bounded if it is bounded above as well as bounded below. If these both conditions will satisfy, then this will call a bounded set. For example, we have some example. We'll find is it a bounded or not. Okay, first of all, it is what? It is bounded above. Okay, I will write just BA. It is bounded above. Is it bounded below? Okay, first I can write is like this. Here, it is bounded above, bounded below, and then bounded. Okay, so it is what? Phi is bounded above? Yes. Phi is bounded below? Yes. Then phi is a bounded set, of course. Natural number is bounded above? No. Is it bounded below? Yes. 1 is the lower bound of this. Yes. So it can't be a bounded set. It is what? Bounded above? No. Not bounded below. It will go up to minus infinity. Then it is not a bounded set. Similarly, for this, it is not also bounded set. For this, it is not a bounded set. For this is also not a bounded set. Complex number, this is also not upper bound, not bounded below, then it is also not a bounded set. Similarly, we have some another set. For example, 0y. We'll just write the same thing. Bounded above, bounded below, and then we'll just round bounded. So, for that, this is what? Is it a bounded above? Yes, it is a bounded above. Is it a bounded below? Yes, it is a bounded below. Less than 0, any kind of number will present there, then it will be lower bound for this particular interval. So this is a bounded set. Is it bounded? Yes, it is a bounded below as well as bounded above, and it is a bounded set. This is what? It is basically, what is the bounded upper bound for this is 1 and lower bound for this is 0. It is basically set is kind of like this 1 by 2 and go up to, if n tending to infinity, then the last term will be 0 for this particular set. It means it is the lower bound, it is the upper bound. So for this, it is a bounded above and bounded below, so it is bounded set. Similarly, this is also bounded set. Okay, singleton set is always a bounded set. Okay, this is one of the singleton set, means and only one element is there. Similarly, this is also bounded above and bounded below set. So this is called the bounded set. Okay, so now here we have some result. Any finite set A is a bounded set. For example, this one. This is what? 1, 2, 3. This is my finite set. The cardinality of this set is what? Cardinality is 3. There are 3 elements present in this. So this is my bounded set. For example, 0, it is what? Finite set. The cardinality is 1. Okay. So this is called my bounded. Each and every finite set will be of real number will be or this will be the subset basically will be the bounded set. Any infinite set may or may not be bounded. Any kind of infinite set, we can't say it will definitely be bounded or definitely be unbounded. It may or may not be bounded set. Okay, next we'll come to supremum or least upper bound of a set. Just remember the thing. What is bounded above? Okay, bounded above. Bounded above, just visualize this thing. This is my set and this is going to be the last element of my set. Okay, after this particular boundary, every element will be the bounded above. For this particular element, every element will be the bounded above. But we are talking about supremum, or another name is that least upper bound. Means these all are my upper bound. Okay, these all are my upper bound. But what is the least upper bound? It means what is the least value among all these values? It is what? This thing. So just next upper bound is going to, or we can say the first upper bound is called as least upper bound. It means from here it is called supremum. The same thing, if it is my last element, or the the first element, we can say whatever, we can assume, we can just visualize the thing. After that, every number will be my lower bound, then this greatest value. Okay, from this, because it is a negative, from negative it will be a greatest, and from this it will be a least one. Just remember this thing. This will call the infimum, and this will call the supremum. So least upper bound and greatest lower bound will be the concept of supremum and infimum. Sorry. Okay, so the definition is what? Let A is subset of R be a bounded above set. Okay, bounded above set of real number. Then then A has infinite number of upper bound. Okay, we have noted that infinite number of upper bound. Then the least upper bound is called supremum of set A. Okay, that will be the supremum of set. And similarly, let A is subset of real number be a bounded below set of real number, then A has infinite number of lower bound. Then the greatest lower bound is called infimum of set A, the greatest one. Okay, the greatest and the least upper bound. So this is the concept of supremum and infimum. Okay, it is denoted by this SUP of A and I and F. Okay, infimum of A. So there are some result on the basis of this, and of course we'll find the supremum and infimum of for all these things. So first of all, we have some results. Okay, one second. Yeah, we have some result. So supremum of a bounded above set, supremum of a bounded above set, and infimum of bounded below set is unique. Whenever we have, just visualize that thing. If it is A, then it is my last number from right, and this is my last number in left. Just assume any interval or any kind of set. Then the just lowest number will be 1, and just highest number will be 1. It means my bounded above, if it is also what? It is what? Bounded above, and it is bounded below. Supremum of bounded above and infimum of bounded below of a real number set is always unique. Of course, the supremum and infimum will be the unique. This is the first result. After that, supremum or infimum of a set A may or may not be belongs to that set. It means it may belongs to the set, or it is not belonging from the set. Not necessary that every time it must be belonging from the set. For example, I have I is equals to 0 and 1. But remember, 1 does not belonging from I, but the supremum of I is 1. Similarly, the infimum of I is 0, but 0 is does not belonging from this interval. This is the result. Next one is that supremum or infimum of a set which is subset of real number may or may not be exist. It is not necessary that every time supremum will exist. For example, I is equals to 0 to infinite. In this case, supremum of I will does not exist. And similarly, if it is minus infinite to 0 or whatever it will be, then the infimum of in this case does not exist. Okay. Next, for a bounded above set A, okay, because of, see, one thing is that it is not bounded above, then supremum may or may not be existent. Of course, if it is not bounded above, then we can't say about the supremum. There will does not, like, there does not exist any kind of upper bound. How can we find the least from that upper bound? There is no upper bound is there. Okay. Similarly, there is no lower bound is there. How can we find the greatest of the lower bound? Okay, this is the thing. For a bounded above set, the supremum exists, and for bounded below set, the infimum exists. If a set is bounded above, then of course there will be infinite number of upper bounds will be there, and we can find the least from least among all the the upper bound. Similarly, if it is a bounded below set, then there will exist infinite number of lower bound, and we can find the greatest upper bound. Okay, greatest, no, the lower bound, sorry, not upper bound. So this is the thing. Real line is complete order set. This is what complete order set means, that there is no hole in real line. There is no gap, or basically we can say hole. Okay, there is no hole in real line. It is continuous. Whatever, if I will put my pen here, of course there is a number. If it is 0 and 1, if I will put up my pen or needle on any point, of course this will be a number. There is no hole. It is a continuous thing. There, even though 0.0001 and 0.0002 has infinite number of points are there. This is the importance, and this is the property, or this called the completeness property of real number, and it is called there is no gap, means real number is a complete ordered set. Next one is that if yes, okay, 1 second. If I have A, okay, if I have set A is subset of B, if I have set A subset of B, it means then the supremum of A is less than supremum of B. It's the result. Similarly, the infimum of A will be greater than infimum of B, and also the infimum of B is less than, the order is basically infimum of B. Okay, so infimum of B, then infimum of A, then supremum of what? A, and then supremum of B. Okay, so this will be the order of infimum and supremum whenever A is subset of B. Next one, if there is a set A, and if we'll multiply with any integer k, okay, then if my k is belonging from Z, so what is the supremum for this? So k will be the supremum. Okay, it will be k into supremum of A. So supremum of k will be the k into supremum of A if my k is greater than or equals to 0. If it is a positive integer, we can say it is a positive integer. Similarly, if it will be k into infimum of A if my k will be less than 0, or it will be negative. Okay, similarly, we have another property, that is basically, 1 second, yes. So next we have infimum property. Okay, in this case, this will be k into infimum. This will be k into infimum of a if my k is greater than equals to 0, and it will be k into supremum of a if my k will be negative. So you can see just opposite thing. If k is negative here, then supremum of ka will be the k into infimum of, and if it is infimum of ka, then it will be supremum of k into supremum of a if k will be negative. Is the just opposite thing. So next we have a comma b belong a comma b. The set of a and b are the set of R, and a plus b will be represented by x plus y, where x is belonging from a and y is belonging from b. Then we have some result. What? Supremum of a plus b is nothing but supremum of a. These are the algebraic of supremum and infimum. Similarly, the supremum of a minus b is nothing but supremum of a, but if it is minus, then it is nothing but minus of infimum of b. And another property, this is one of the property. Okay, and okay, these are two property. Similarly, if you will find the infimum of a plus b, then this will be the simple linear addition. So infimum of a plus infimum of b. If it is a infimum of a minus b, then it will be infimum of a. Whatever the minus, it will get converted to the supremum of b. Okay, this is the part here. Okay, next one thing, it's the minimum and maximum set. Will find 1 second. This will be here, this will be here. We'll compare what is the maximum and minimum of maximum element, minimum element, and what is the the supremum and infimum. We'll find it. Okay, so after that we have for positive real number set a and b. If a and b are the positive set of real number, then first one, supremum of a into b is nothing but supremum of a into supremum of b. But whenever you are going to calculate the supremum of 1 by a, okay, supremum of 1 by a, it is nothing but 1 upon infimum of a. This is the potent result here. Next one is that supremum of a union b. This will be the maximum of, this is obvious. If you are going to union, if you are going to add, union means add, then you will take the maximum value, because that may be the upper bound. For example, the supremum of a exists here, and supremum of b exists here only. Then what will be for a union b? Now this will be the set. And what is the upper bound? Starts from here only. Then least upper bound will be find here only. Okay, so it will be the maximum of this. Okay, so we'll find the maximum of supremum of a and supremum of b, and after that, to get the infimum, will of course will find the minimum of infimum of a, minimum of infimum of a and infimum of b. So these are the result. Now, what is the concept of maximum element and minimum element? See, maximum element and minimum element, and we'll compare what is the difference between maximum and supremum, minimum and infimum. So maximum element for a set, definition is, for a set A is subset of real number. It means the set of real number. A real number L is said to be maximum if, what is the condition? Condition is that L belongs to that set, first thing. And another thing is that every element for x is less than equals to L for every x is an element of, each and every x is element of A. So this is the main part. Okay, this is the part in which we are calculating the upper bound, but it is not necessary that we have written the property that supremum or infimum may or may not belong to the set. But here it is necessary that this maximum element must be from the set only. And the same thing is going to be here for a set A of real number, then a real number, we can write it as M, is said to be minimum if first thing is that it must be, or M must be belonging from A, and another thing is that M should be the greatest one, or not, M should be the least one from all the X for every X belonging from the set A. Okay, so this is the part. Now we'll compare what is the difference between maximum and minimum. How can we differentiate these both? So just see, if maximum or minimum element of set will exist, if this will exist, then maximum of A or minimum of a set must belong to the set A. It is what? Not necessary that supremum or infimum is belonging from the set. Okay, one thing is that maximum and supremum, minimum or infimum may equal. Maybe these both will equal, but it is not necessary at each and every time. Okay. Another thing is that for bounded set, a maximum of A or minimum of A may exist. Okay, may exist. But for a bounded set, supremum and infimum will exist. This is the property. Both will exist whenever the set is bounded. For example, the maximum of a set A, 0 and 1. Maximum is what? Here, maximum is what? For this, we can't, like for this, maximum will be the supremum of A, and we can say that, okay, one thing is, maximum may be the supremum, and the minimum of a set may be the infimum of A. Okay, but the thing is, it is not always necessary. It is not always. We can write here, not always. Next we have some example. We will find supremum, infimum, maximum and minimum element for the examples. We have lots of example and we'll find. So see what is here. First I will find the supremum. Supremum means, just keep in your mind the sign. Either it is a positive or negative. What is this? This is -2, -1.5, okay, -1.3, and it will go up to what? Whenever these both digit will get equal, it means this is going to 1. Then what? The supremum of, I will just write here, supremum is, for this, supremum of A, or I can just write like this, supremum of A is minus of 1. No, obviously minus of 0.9 is also be the greatest one, greatest upper bound, or not, like upper bound will be there, but it is the least upper bound, then it is called supremum. What is the infimum for this? So infimum for A is going to be least, but the thing which is greatest, so it will be minus of 2. While we are going to calculate the maximum of A, what is the maximum? Will it be reach minus of 1? Of course not. It is tending, not exactly -1, so it does not exist. But while minimum of A, this will exist. This is here only, that is minus of 2. This is -2. This is nothing but your minimum of this value. No value is minimum 2. No 2.1 is there. No 2.2 is there. But 2.1 is the upper bound. From that on, sorry, not that upper bound. 2.1 is the minus 2.1 is the lower bound. From that all the lower bounds, minus 2 will be the greatest lower bound. That's why we are saying it as infimum. After that, see this. It is what? 1. And after that, it will be 1.5. Okay. 1.5 plus 0.25, 1.75. It means this is also going to be, in this case, this thing will going to 1. It means it will be 1 plus 1. So the supremum of A will be 2. Similarly, if I will talk about infimum of this set A, then this will be 1. This is 1. Now the same thing is here. If I will find the maximum of A, of course does not exist. It is tending not exactly equals to 2. Okay. And after that, the minimum is present in this. So minimum of element is 1 is here. For this element, my n is not equals to 0. Okay. In that case, supremum is what? Supremum of A. In this case, if n tending to infinity, then it will be 0. But what is the value? If I will start with this 1 by 1, I have taken the example, same example. So this is what? So my supremum will be 1 here. What is the infimum? It may go up to minus because it is an integer part. So it may go up to minus. So A, then it is minus of 1. So what is the maximum value of this? Of course, now at this time, the maximum value for this will be 1. But after that, this will be decreasing. Okay, like this. This will be 1. Here it will be decreasing. Here it will be decreasing. Okay, this is the thing. So the maximum is 1. Okay, and same, what is the minimum of A? So the minimum of A will be minus of 1. In this case, supremum, maximum, infimum, minimum are equal. Same thing for this. Now my n is belonging from natural number. So what is the supremum of A? So the supremum of A will be 1. But at this case, my infimum will be 0. How? As n tending to infinity. Now there is no, because there are only positive integers are there. So my infimum of A will be 0. Here in this case, maximum of A will be 1, but minimum of A, it is tending to 0, not exactly 0. So minimum will not exist. The same case here, what is this? This is going to be 1. It is what? Natural number. So 1 minus 1 by 1. Okay. And after that, it will be plus 1 upon 1 by 2. So this is going like 2. Okay. This is going like this. This is what? Comma is here. So in this case, my supremum is what? So the supremum of A is 1 plus. What is that? N tending to infinity. But okay, not infinity. If it will be 1 plus 1, then it will be 1 plus minus 1 upon 1. So it will be 0. But after that, if it will be like this, minus 1 square upon 2, then this is what? 1 plus 1 by 2. Then this will be 1.5. This will go up to what? 1.5. There is no other thing will happen, because if it will be like positive, then if it will be when it will be positive, it will be even. Then 1 plus minus 1 power 4 upon 4, then it is what? 1 plus 1 by 4, that will be 1.25. No, not greater than 1.5. So the supremum will exist at only 1.5. So the supremum value will be 1.5. Okay, this is 1.5. Similarly, the infimum of this A. What is the infimum? Of course, n tending to infinity. If my n tending to infinity, then or not n tending to infinity, but if n tending to infinity, then it will be 1. But here, if my n is equals to 1, then 1 plus minus 1 upon 1, this will be 0. No negative value will be there. So for that, 0 will be infimum. Now for here, what is the maximum value of this? Of course, the maximum will be 1 plus 1 by 2. And the minimum will be here, means like 1.5. or we can say minimum of A is also 0. So here minimum and infimum are equal. We have another example like this. So in this case, supremum, we can easily find supremum will be what? In this case, supremum will be my, one second, if it is like this, no? So positive, then 1 plus 1 by 4 plus like 2 power 2, okay, minus 1 power 2, and it is what? Minus 4 by 2, then it is what? 1 plus 1 by 4, and it is 2. Then in this case it will be 4, then 4 plus 1 minus 8, okay, then this is nothing but 8 plus we can write it as 5 minus 8 by 4, but it will be negative. So the maximum value for this case is 15 by 4. Okay, you can see here it is 15 by 4. When you will put any positive value here, okay, like 4, or otherwise it will be not 4, or any kind of even number if you will put, then you will get this is the maximum number. Okay, this is also going to be the maximum of a 15 by 4, and the infimum of a in this case will be minus 7 by 4 that we have already found. Okay, next, this is one of the important, 1 minus 1 by n sine n pi by 2. See, the maximum, the bound of the sine or any sine and cos in the trigonometric, that is minus 1 to 1. So it is what? In this case, it will be 1 minus 1 by n, or it may be like, or in this case, this is what? Sine value can be 0, minus 1 and plus 1. So in this case, the supremum will be always 1, because if my n tending to infinity, then it is what? This will be 0. If it will be 0, it is 1, and its maximum value is what? 1. Then in this case, the supremum of A is 1. Similarly, the infimum of A. So what? If it is 1, and if it is minus 1, minimum value of sine is minus of 1, then it will be minus 1. But here, maximum and minimum value does not exist, because it is approximate value, not exactly tending to that particular value. Yeah, in this case, we have the same thing, but here you can find the maximum and minimum. How? What is upper bound? Of course, supremum of A is 1, infimum of A is minus 1, and this is also going to be maximum of A, and this is the minimum of A for this case, because now here no 1 minus n will be there, means no infinity will be there. Okay, so this is the thing. Next, we have this kind of, whenever you have this kind of example, then you should apply like this. Okay, one second. So basically, whenever you have this kind of example, then you have to fix one thing. Okay, you can fix one if it is like this, like m and okay. Now, if my m and n both are 1, then it is what? The maximum value will be 2. Okay, this is what? 1 plus 1 upon 1, it will be 2. Otherwise, it will be what? The 2 plus. So the maximum, we can take any kind of thing. If my m is just infinite, if my m is infinite, then it may be infinite. Okay, in this case, it is also going to be infinite. So here it is what? My supremum can be infinite. Okay, because of that, I can take any kind of value from the natural number of m. It will be infinite. But what is the infimum? Infimum we can take only, what is the least value we can choose from the natural number? That is 1 only. 1 plus 1 will be 2. Or in this case, if we'll take m is 1 and n is infinity, then it is what? 1 plus 1 upon infinity. That is what? 1. Or if we'll take both value 1, then 1 plus 1 will be 2. Which one is lesser? This one is lesser, na? So we can take just infimum as 1. So the infimum of A is 1 here. What is the maximum and minimum? Of course, the maximum and minimum will not exist, does not exist for this particular question. Okay. Next, we have sine and cos thing is here. Of course, for this minus 1 and 1 will be the bound. So we can find supremum of A for this is 1 and infimum of A is this 1. Infimum of A is 1. For this particular question and for this particular question, the same thing will be happen. But maximum of A and minimum of A does not exist. Okay. The same thing you can find here also. So in this case also we can take supremum will does not exist. The same thing. Supremum will be infinite for this case because I can take any number m tending to infinity and tending to infinity. This thing will go to infinity. But what is the minimum value we can take? If we'll take my m is equals to 1. Just see, m is equals to 1 and n is equals to 1. Okay, these both are lesser value. So here I will take 1 upon 1 plus 4 upon 1. Then this is what 5 is going to. But just to see for a second, if I will take, okay, if I will take m tending to infinity, or one thing is that, wait. If I will take m is equals to 2, then what will happen? M is equals to 2 and n is equals to 1. Then it will be 2 upon 1, 4 upon 2. Sorry, plus. Then it will be 2 plus 2. It is 4. It is what? 5 and it is 4. So which one is the minimum? This one is the minimum. So the infimum will go to, like infimum is going to be 4. So my 4 is going to be infimum. So supremum, of course, for this is infinity, does not exist. We can say, okay, does not exist. But infimum we can say is 4. And maximum and minimum will not exist for this. The minimum is also this. Minimum value is this, but not maximum. Maximum will does not exist for the same case. In the same thing here, if it is m plus n. Now, what will happen? If I will take, if I can write like this, m plus n minus n upon m plus n, this is what? This is 1 minus n upon m plus n. Now here, if I will take m and n is 1, then this is going to 1 minus 1 by 2. This is what 1 by 2 is here. But the thing is that, what can be the, wait, yes, what can be the 1 minus 1? So my infimum is what? 1 by 2. Other than that, I can't find anything, but one thing is that it is belonging from natural number. No? If I will take 1 minus 1 by 2 upon 1 by 2 plus 1 by 2, then this is what? 1 minus 1 by 2 upon plus. This is going to be 1 by 2. I think no infimum value less than 1 or no other value will be will exist for this particular case. So supremum is what? 1. Supremum I can find with this m and 1. This will be the supremum. I can find the value is supremum. And the infimum in this case is going to be 0. If my m tending to infinity, if I will take m tending to infinity, then this is going to 0. This will be the infimum, but not maximum. So the maximum and minimum does not exist for this case. Okay, here in this case, you can take m from integer. It means my minus 1 will be allowed here. So it will be minus 1 m upon mod of m plus n. This will be the bound for this. You can take any value. So the supremum of A will be 1 and the infimum of A will be minus of 1. But the maximum and minimum value does not exist for this case. The same thing we have for this case. We'll fix m and n. For this we can put what? If my m tending to infinity, it will be 0 and m n 1 plus m plus n. And of course it may go to infinite if it is m and n are belonging from natural number. It means my supremum is equals to 0, infinite means does not exist, but infimum is 1 whenever my m tending to infinity. Okay, then this will be or m and we can write infimum will be 0. For this case also, this is the same thing. Okay, now the infimum of we have another question. So 2 power x plus 2 power x minus 1, where x is greater than 0. If my x is greater than, if it is x is greater than equals to 0, here my x is greater than equals to 0, then what can I write here? If my x is greater than equals to 0, then I can just simply write 2 power x plus 2 power 1 by x. I can just write, one thing is that, let me remember. This is what? This is going to be greater than of root 2 of x, 2 power 1 by x. Then again, this will go to root 2 or 1 second. Just let me write it again. This is what? 2 power x plus 1 upon 2 power 1 by x. So this is nothing but 2 power x into 2 power 1 by x plus 1 upon 2 power 1 by x. Okay, and it can be written as, if we will write it as, 1 second, yeah, 2 power x plus 1 upon x plus 1 upon 2 power 1 by x. This is going to be 2 of x square plus 1 upon x plus 1 upon 2 power 1 by x. And after finding this, if my x will be 0, then it will be infinite for that. But here, what may be the value of this? 1 second, there is a problem in this, I think so. Okay, the infimum is to be found. Sorry for that. Yeah, but one thing is that infimum, what is the minimum value? Of course, the maximum value may be the infinite for this, but we have to find the infimum only. Okay, so the infimum value will be only if I will put like x is equals to 1. If I will put x is equals to 1, then 2 plus 2, okay, minus 1, then it will be 2 plus 1 by 2. It is going to, if I will put 0, no? We can't put less than 0, then it will be not 0. If I will put 1 here, 1 minus 1, x is equals to 1 will be the infimum value. Okay, then it will be 2.5. But we can find like this. So 2 power x, it is not minus, I think so. If it is plus, then we can do something. If it is not plus, then we can do something. Yes. So there was a problem in this. If it is minus 1, then 2.5 is the infimum, but here it is plus. So it is 1 plus 2 power 1. Whenever we are going to put x is equals to 1, then this will be 4. So this is the infimum for this. Yeah. And the supremum for this, of course, we can take x tending to infinity. So the supremum for this is infinite. Oh, yeah, similarly, we have some another kind of question. We can also discuss this kind of question. So in which we have first A. What is A? First 19th question is here. That is given that x such that x belonging from real number such that x minus A, x minus B, x minus C and x minus D is less than 0, where A less than B less than C less than D. Okay, C and less than D. So for this, how can we find the infimum and supremum? First of all, we have to find A, and first of all, we have to find the A. So we can just plot. How can we plot this C? We have this. Okay. Oh, yeah. 1 second. Yes. Here, so if we plot this polynomial or this polynomial, then how can we get? For example, this is my A, B, C, sorry, D. Then, okay, if it is my A, B, C, D, then it is less than, okay. So one thing is that it will be what? X power 4. This is what? If I will multiply, then highest degree will be 4. It means it will be positive. It will start from positive. So this is positive and this will be negative. So will start from positive. So this behavior will go to like this. Okay. Then what is going to be? Okay, just see what is the A. A is nothing but we can just write A comma B. The scene is what? A comma B union C comma D. We have to take the negative part. What kind of? This one is negative part. So this will be my set. So A comma B union C comma D. Now what is the supremum in this case? What is the supremum? Only the negative part should be taken from this. So the supremum from this is nothing but D. So D be my supremum. And what is the infimum from this? So A be my infimum. Now we will take example number 20. So in example 20, we have A such that, okay, one thing is that in A, what is this? It is x cube. Highest degree will be x cube. In B, it will be x square. It means this may be negative. It will be negative for every x belongs to negative integer or negative real part. Okay, but this will always greater than for every x belonging from real number. And what about C? It is x cube again. Okay, and what are the roots here? Roots are x is equals to 0, 1 and 2. From here 0 and 1. From here x is equals to 2, 3 and 4. Okay, so we'll plot accordingly. First we'll plot A. So if we'll plot A, then wait. So my A will be like this. Root of A is 0. Okay, root of A is 0 and 1 and 2. And it will be it is what? X cube. And here it is given that it is less than 0. What? It is less than 0. It means it will start from here, negative, from the negative part, like this. Okay, so 1 second. This will start from here like this. So it is what? Minus infinity and go up to infinity. So what is my A here? So see, what is the supremum for this? This will be the supremum, because after that this will not get content. But here just see what is we are just calculating the negative part. Okay, so from here the supremum of A is going to be B, is 2, and the infimum of A is going to minus of infinity. This will be the infimum. And the same thing for B. If we are going to plot it, then we will have, okay, then we have the roots are 0 and 1. See, the roots are 0 and 1. So here it is 0 and it is 1, and it will be square. So it will start from this. So it is what? This is my 0 and this is 1. So for this, okay, for this it is what? Minus infinity to 1, negative part, and from here 1 to 2. And from here it is what? Minus infinity to 0, union 0 to 1. It means the supremum of B is 1 and the infimum of B is 0. Okay, yeah, we have to take the negative part only. So my set B will be only this, not this. Okay, this will not be there. So this is my set only B. So the only negative part will contain here. And similarly C, it is what? If I will plot this, okay, if I will plot this, then this will be, the roots are 2, 3 and 4. So this is 2, this is 3 and this is 4. And this is what? Less than 0. If it is less than 0 and it is cube, then this will start from here. So negative, positive, then negative. So from here what? Minus infinity to 2, we are taking it. Minus infinity to 2, and union of what this is. This is the part and this is the part 3 to 4. So what is the supremum of C? It is 4, and infimum of C, it is minus of infinity. So this is how we can find the solution. And next, we have characterization. What is the characteristic of supremum of a set? This is the theorem. A necessary and sufficient condition for real number L is to be supremum of bounded above set A if that x belong this that like x less than equal L for every A, and this is for like the another epsilon theorem. Epsilon is greater than 0, then y belongs to this. If we will minus epsilon is very small quantity from that L, which is supremum, then it will be inside the set. This is what, if I will minus epsilon from this, then this will contain in this particular set, that will be not your supremum. So this is just the characteristic of this, and this is the theorem, this is the result. So I hope you have understand the full concept of these all topics, basics of sets, bounded, unbounded, supremum, and infimum. In the next part, we'll discuss these properties: Archimedean property, open set, closed set, limit set, derived set, Bolzano-Weierstrass theorem, cluster point, dense set, and boundary points and interior points also we'll discuss in the next lectures. Thanks for watching my video. Keep watching MS Maths. We'll see you in the next video. Thank you. Bye-bye.